Hi again, sports fans. I have a bit of a sequel for you. This lesson is more on coin problems, also known as setting up systems of equations. Welcome back. If we are just meeting, my name is Mark Nolde. I have been teaching high school math for almost 25 years. So today we're looking at some of my favorite problems, coin problems. That means the skill we need is solving systems of equations. So the hard part on these is setting them up. After that, it's usually smooth sailing.
So here's example number 1. It says, Chandler and Monica have 51 dimes and nickels. If the value of the coins is $4.10, how many coins of each type were there? So whenever you do these problems, what you're always looking for is there's going to be one statement of quantity, and there will be another statement of value. So statement and value, quantity and value. So the very first sentence here, Chandler and Monica have 51 dimes and nickels. So that's my quantity statement. So dimes, I'm going to let D equal the number of dimes, plus N, that's the number of nickels, is 51. There's a total of 51 coins. So this is just the number of dimes, this is just the number of nickels, and the total number of coins is 51. So the second sentence here, if the value of the coins is $4.10, how many coins of each type were there? Well, I know a dime is worth 10 cents and a nickel is worth 5 cents. So I'm going to write down 10 times D, 10 cents per dime, plus 5 cents per nickel. Now I have to be careful here. This is in dollars, and I'm writing these in cents. So I have to write 410 cents here. So this is going to be my system of equations, and we like to be neat. We number these 1 and 2. Sometimes people will number them A and B. But what I'm going to do is use substitution, because this is a D and an N. So, and I have a 10D and a 5N down here. So it's usually easier, since this is smaller, I'm going to solve for N up here in number 1. That way, later on, I won't have to deal with a negative. I could still deal with it, but why deal with negatives if you don't have to? So solving the first equation for N gives us N equals 51 minus D. So now we go to the other equation, and 10D plus 5N. So I'm going to substitute in place of the N 51 minus D. And that is still equal to $4.10 or 410 cents. So distribute your 5 here. So that will give us 10D plus, 255, right? 5 50s is 250 and 5 1s is 5. So 255 minus 5D. And that is equal to 410 cents still. So add your like terms, and notice by doing it the way I explained earlier, I don't have a negative here. It's a positive. So I'm not going to have to deal with negatives. So 5D is equal to 410 minus 255. Let's see, what is that equal to? 155? So 155. And D must then be equal to 31. So there's 31 dimes. Now that I know how many dimes there are, I'm going to go back to this equation. It's already solved for N, and that's equation 1. So N equals 51 minus 31. That's the 31 I just solved for. So N is going to have to be 20. 51 minus 31 is 20. And if you have, just double check sometimes, if I have 21 nickels, that adds up to $1. And if I had 31 dimes, that adds up to, 31 dimes. So 10 cents per dime. That adds up to $3.10. And when I total that, I get $4.10. So that was, that double checks with my problem that had $4.10 here. So I can go ahead and give that a blue check mark. All right, let's look at example number 2. All right, so here is example number 2. This one reads, when the piggy bank was smashed open, it yielded $475 in ones and fives. So this one's about bills. If there were 175 bills in all, how many were ones and how many were fives? So, again, a quantity statement is one thing that we're looking for. So I'm going to write down quantity. I'm going to write it down in easier to read color though. So quantity, and I'll abbreviate it, and value. So, let's see. This second statement, says it yielded $475 in ones and fives. So that is a value statement. So I'm going to write that down first. So my first equation is I have to pick variables for ones and fives. I guess I'm not going to pick an O for ones because an O looks like a 0. So maybe I'll use S for singles. So the number of singles, $1 per single plus $5 per five. I'll use F for the number of fives. And that's supposed to be equal to $475. Now notice on this one, I don't have to turn it into cents because 5 is in dollars and 1 is in dollars. So these two are not in cents. So now my quantity statement is, 175 bills in all. So S plus F equals 175. So I like this system of equations because it's going to lend itself to elimination. So I'm going to subtract the second equation from the first equation because when we add equivalent equations, that is equations that have the same solutions, I'm going to create another equivalent equation. So equation number 1 minus equation number 2. So those add off. And let's see, this becomes a minus. So 4F, 5 minus 1 is 4. And this is nicely works out to be 300. So 300 divided by 4 is what I have to do there. So I guess F is 75. So now that I know what F is, I can go back up to one of the other equations and substitute. I'll probably go back to equation 2 because that was an S plus F. That one was a little bit easier to deal with. So if 75 were fives, and let's see, how many S's were there, singles? Well, that nicely works out to be 100 singles because we're subtracting 75 on each side of this equation. So that's how we get our S. So let's see, if I have 100 singles that are worth $1 a piece, that's $100 in singles. And if I had 75 fives that are worth $5 each, let's see, 75 times 5 on my calculator says 375, and that's a good thing because together these add up to 475. So we'll give that a blue check. Okay, for the third and final example, this one reads, there were 10 more Sacagawea dollars than there were Kennedy half dollars. If the total value of the coins was $100, how many Sacagawea dollars were there? So they're only looking for the number of dollars. We can figure out both, but it's not asking for the number of halves. So again, let's go and look to our statement of quantity and our statement of value. So let's see. I have a quantity statement, it looks like. First, there are 10 more Sacagawea dollars than there are Kennedy half dollars. So I'm going to use, I guess, D and H for my variables. So dollars, let me see here. Dollars is going to be equal to the half dollars plus 10. So sometimes it's easy to confuse these, but think of this as like, I don't know, a teeter-totter. Okay, it balances on the equal sign. There are more dollars than half dollars. So I have to add 10 to the half dollars to make this equation balance. So this is frequently confused. So be careful on that one. So that is the quantity statement. Now we're going to look to the value statement. And I see I did not make a very good E there. All right, so how much is a dollar worth? Well, a dollar. So I'm going to write it as 100 cents. So 100 cents per dollar plus 50 cents per half dollar. And that equals a total of $100, which is 10,000 cents. So we have our system of equations. So be a good little equation solver and number those. And let's see. The first equation is already solved for D in terms of H. So maybe I'll just substitute a D, H plus 10 in place of this D. So let's go ahead and do that. 100 times D plus 50H equals 10,000 cents. So that is, I'm going to put this value in place of the D because that's what D is equal to, H plus 10. So I can use substitution and do this. Then I'm going to distribute. Oops, let me change back to my yellow. Here we go. 100 times H is 100H plus, that was that one, 100 times 10. That gives us 1,000 plus 50H equals 10,000. So let's see. Let's combine our like terms. I have 150H plus 1,000 equals 10,000. And then in this next step, I'm going to subtract 1,000 on each side. So that equals 9,000. So if you type 9,000 divided by 150 into your calculator, you will see that the number of half dollars is 60. And I'd probably come back up here to this equation, equation number 1, because I've been dealing with equation 2. Ooh, I got sloppy. So D equals the number of halves, half dollars, plus 10. So there must have been $70, 70 of those Sacagawea coins. So again, go ahead, double check. 60 times 50 cents, because it says there's 60 half dollars. So that would be $30. And then I have 70 Sacagawea dollars at $1 a piece. So that is a total of $70. And they do, in fact, add up to 100. So here's my 100. So that works out nicely. All right. I hope you like those two examples. Go ahead and smash the like button.
I hope you like those coin problems. If so, go ahead, like and subscribe. I'd really appreciate it. And as always, don't forget, math is not a spectator sport. If you want to learn math, you have to do math.